Hi third year and welcome to this lesson on alcohols as a homologous series. As we go through today's lesson, you'll need your jotter, something to write with, and you'll also need your Unit 2 booklet. The prior learning you will need to be able to complete today's lesson is, first of all, I can define homologous series. So remember, we already know two homologous series, the alkanes and the alkenes. And the alkanes and alkenes can both be called homologous series because they've got a general formula. So for the alkanes, CnH2n plus 2, for the alkenes, CnH2n, and because they have similar chemical properties. So remember, for example, all alkenes can undergo addition reactions because they've got a double bond. So that's what homologous series is. Same general formula, similar chemical properties. I can define valency. Valency is the combining power of an atom, and it's to do with how many unpaired electrons each atom has in its outer shell. We need to be able to know the valencies of carbon, hydrogen, and oxygen. So remember, it's to do with the group number as well. So carbon's valency is 4, hydrogen's valency is 1, and oxygen's valency is 2. I can use the prefixes meth, eth, prop, and then but, pent, hex, hept, and oct. And remember, those prefixes indicate how many carbon atoms there are in the molecule. And we need to be able to go between the different representations of formula. So names and molecular formula, shortened structural formula, and full structural formula. Today's learning then. So I can name and draw full structural formula, shortened structural formula, and molecular formula for the alcohol family. So for all the alcohols up to 8 carbons in each molecule. So if you were given any of those, so if you were given the name of one, you could draw it. If you were given the shortened structural formula, you could say what the name is. And you need to be able to identify that they are alcohols. Okay, so if you were shown a structural formula for an alcohol, you should be able to say, I know that is an alcohol. And then state the general formula for the alcohol family. So we'll come back to those later to make sure we can do them confidently. Let's think about alcohols now. Okay, so the alcohols, like I said, they're homologous series. Okay, they're a new homologous series. And it's helpful if we relate to the homologous series that we already know about. So let's think about the alkanes. And the first member of the alkanes is methane. I've got a little model of methane here. Okay, we can see we've got the carbon atom in the middle and 4 hydrogen atoms surrounding it. Okay, now this is a hydrocarbon because it's got hydrogen and carbon atoms only. Okay, when we're thinking about the alcohols, alcohols actually are different from the alkenes and alkenes because they also have oxygen. So in order to show you what the first alcohol looks like, I'm going to change the structure of this slightly. So this is methane right now, and I'm going to take off this hydrogen atom, and instead I'm going to put on an oxygen and hydrogen. Okay, so I've got still meth, okay, or meth. Because I've got just one carbon, but then I've got this OH. So I had just an H before, but now I've got an OH. So this is actually methanol, and it's the first member of the alcohol homologous series, methanol. The next member of the alcohol homologous series has 2 carbons in it, and it is ethanol. Okay, so 2 carbon atoms and an OH group. Okay, so this was methanol, 1 carbon and 1 OH group, and this is ethanol. The next member of the homologous series then would have 3 carbon atoms. Okay, so we've got 1, 2, 3, and then the OH group. So this is propanol. Okay, so prop because it's got 3 carbons, and then it's still got this OH group. And then we've also got butanol. So butanol, 1, 2, 3, 4 carbons, and then my OH group. So the naming of them, you're noticing it's the same as how we named alkanes and alkenes with meth, eth, prop, but, and so on. But the ending of the name, instead of being ane or ene, it's now all. Okay, so that's a brief summary of what the alcohol structure is like. If we're to think about what the formula would be, let's go back to our methanol. So we've got 1 carbon here, and then we've got 3 hydrogens, and then we've got our OH. So if I was to give the formula for this, I would say CH3OH. Now you might be wondering, why did I not just group this H within the others? Why did I not just say CH4O? Well, the reason is because when we look at a molecular formula, we want as many clues as possible about what the actual compound is. So if I leave this H and group it with the O in the molecular formula, then I'll know from the molecular formula it's an alcohol because it will be OH, just like it is. So I give the molecular formula for this as CH3. So that's everything that's not in the OH group, and then OH, CH3OH. Same with ethanol. So I would count everything apart from the OH group first. So I would say C2H1, 2, 3, 4, 5. So C2H5OH. Propanol, 1, 2, 3 carbons. So C3H7OH. And then butanol, C4H9OH. I wonder if you noticed what was happening to the numbers of C's and H's, how they were related, and how we might come up with a general formula. Okay, we'll come to that in a wee second. So we're going to come back to our notes on alcohols. So at this point, I want you to make sure you're in your jotter and you've got a heading, alcohols as a homologous series, which is today's lesson, and all of these slides from now on I want you to copy down. It might be helpful for you to try and copy as I talk through, but remember you can pause the video at any time to make sure you've got plenty of time to make sure your notes are complete. So the alcohols are a homologous series. That's really important. They're a new homologous series. Each molecule of alcohol contains atoms of carbon, hydrogen, and oxygen. So remember, that means that they're not hydrocarbons. And the oxygen atom is part of an OH group. The oxygen atom is always attached to a hydrogen. How do we name alcohols? You can put that as a wee subheading, naming alcohols. So they're named in a similar way to alkanes and alkenes. The first part of the name comes from the number of carbon atoms, and the last part of the name is always ol. So, for example, pentanol, octanol. Okay? And so pentanol would be the alcohol with 5, and then octanol would be the alcohol with 8 carbons. General formula. So the formula that we came up with before, we had CH3OH, C2H5OH, C3H7OH, C4H9OH. And what was happening was the number of hydrogens was double the number of carbons plus 1 each time. So that's what the general formula is, CnH2n plus 1 OH. The general formula helps us because it means however many carbons we know we've got, we can always work out how many hydrogens we would have. You can go to page 23 in your booklet now and you can fill it in. The bottom line where it says butanol. So I've shown you how we can draw out butanol and then the shortened structural formula and the formula. So you can make sure that that is complete now. And then in your jotter, I want you to come up with the next 4 rows from the table. So this one, in your booklet, it just goes down methanol, ethanol, propanol, butanol. But I want you to challenge yourself with the next 4. So pentanol, hexanol, heptanol, and octanol. Just a hint, you will need lots of space because the molecules get very large. So, I mean, butanol's got 4 carbons in, so octanol would be double the length of that. Okay. Let's recap then on that learning. So the first thing we were trying to do today was be able to name and draw full structural formula, shortened structural formula, and molecular formula for the alcohol family up to 8 carbons. Hopefully between your booklet and your jotter, you've been able to practice doing that. And for example, so if I would say, what is the formula for propanol? You would say C3H7OH. What is the shortened structural formula for pentanol? And you would give it as is written there. Okay. I can identify the alcohols from full structural formula, shortened structural formula, and molecular formula. So for example, okay, what's that? Oh, that's an alcohol and it's methanol. What's that? Oh, that's an alcohol and it is butanol. Okay, so we need to be able to recognize that they're alcohols, and notice that it's the presence of the OH either written out in this formula, in the structure, sorry, or given in the molecular formula that gives us the clue it's an alcohol. Last of all, I can state the general formula for the alcohol family, and it's CnH2n. CnH2n plus 1 OH. Okay, remember to rewind and then pause if you need to go over any of that learning, but your booklet and your jotter should now be complete.